Hey, hello everyone. Welcome to another episode of Livestream from VoxMeta team. I'm your host Farah, and we're back with another episode of Livestream. Today we got something special lined up for you. As you can see, we have a whole motorbike here. We're gonna be scanning the whole frame of this motorbike and see how H1 Pro performs under real circumstances, right? Or under real conditions. So we have already applied markers on the surface and all the parts of the motorbike. So we're gonna be starting scanning it from the whole body, and then we can move on to scanning the separate parts like wheel or engine or any other part that it needs to be scanned, right? So if you can choose which part of the motorbike are you mostly excited to see it to be scanned out. So you can leave your comment in the chat. And also I want to remind you guys about our Kickstarter program that is about to be finished in 3 days. So you don't want to miss out that chance. You want to grab your 3D scanner with the best price option available for the moment. So we have the link to our Kickstarter page in our live stream room. So you can just click there and head out to our page, right? So now that we got it out of the way, we can move on to scanning. Before we do this, traditionally, of course, we're gonna be conducting the calibration of our 3D scanner, the H1 Pro. As you can see, today we're gonna be using the true wireless mode, so we are not tied to no computer with any cables, so we have a total freedom of movement. That is a super convenient option of 3D scanner H1 Pro. So we're gonna be using it, and now I have my laptop set up here. I put my calibration board here, and for better precision and optimization of the 3D scanner, we're gonna be doing the calibration, right? So let me go to the VoxMeta program. Just click here, calibration. And this way we can calibrate our scanner and optimize its precision, and also warm it up, right? So before using scanner, when you just turn it on, you want to take some time to warm it up. This way your scanner can show you a performance in a better level. So you can just grab any random stuff and scan it before scanning the your goal object. So this way you can warm up your 3D scanner. The calibration is complete. Now we go to the page and choose the markers first. So we start by scanning the markers. If you're new here, you can leave in the comment where you guys watching us from, how did you find out about us, and what are you mostly excited about seeing from our VoxMeta team regarding the 3D scanner. So now we scan the markers on the object first. And then move on to scanning the point cloud, right? So if you're new here and you're not familiar with the specs of our 3D scanner, let me briefly introduce to you our flagship industrial 3D scanner, the H1 Pro. It is engineered for professionals. So this is an industrial grade 3D scanner with an high accuracy of 0.050 millimeters per meter, and for larger objects the volumetric accuracy reaches to 0.050 millimeters plus 0.03 millimeters. And if you use our fiber scale bar, you can achieve the volumetric accuracy of 0.050 millimeters plus 0.02 millimeters per meter. So this is a staggering precision. And also, as you can see on my screen, or in VoxMeta program, we are running at 120 FPS frame rate speed. And also we're capturing 4.4 million points per second. You can witness it in a moment when we start scanning the point cloud yourself. You can see it. You can already notice how smooth and stable the connection is, even though I'm using the wireless mode, completely wireless. So we almost finished with the markers. We long press on a play button and let the program calculate. Okay, they're finished. So we have a powerful chip powered with AI assistance. So the point cloud optimization and other operations on the VoxMeta program are very rapid and quick. So I will tap on the M button 2 times in order to switch to point cloud scanning, and we start from the tail, let's say. All right. Also, let's talk a little about the scanning modes. So right now, as you can see, I'm using high-speed 34 cross-line laser mode. It is designed specifically for wide range coverage and high-speed coverage. As you can see, we are running at 120 FPS frame rate, and we're capturing 4.4 million points per second. So the operation, the scanning process is ultra smooth. All right, we have here the blackish parts. And also you should notice that we are doing an outdoor scanning. So right now we're in an open space outside of the office. Now we'll try to capture all the details on this motorbike. As you can see, this one has quite a lot of complex geometry on it, all these parts. And we'll try to capture it all using the 3D scanner H1 Pro. So right now my point spacing is set to 0.5, as well as my exposure level is also at 0.5. So we're gonna be adjusting the exposure depending on the material type. So for example, if you have some blackish or reflective objects, we have to adjust the points, the exposure level to a higher degree in order to be able to capture it. Because you know the black parts and also the reflective parts are not easy to capture using a default setting of exposure level. So with this scanner, the operation goes really smooth and fast, even though it's a huge object. Again, due to the fact that it is quite a big stuff, so we will take our time and try to thoroughly scan all the intricate parts, all these hidden pockets, and different geometries on here. We'll try to scan it from all angles possible in order to achieve the best possible outcome. So you can see we have carbon parts here. There are also extremely dark. So later we'll adjust the exposure level in order to accurately capture them all. But for now, we'll still be using 0.5 level of exposure in order to fast capture all the simple and easy parts on it, as such parts as you can see on your screen. So yes, stay tuned with us, guys, if you want to see the final result. I'm sure you'll not be disappointed. So if you're new here and you're not subscribed to the channel, hit that subscribe button, and so that you can always keep up with the updates from our team regarding the 3D scanner and also other projects. So I would highly recommend to you to hit that subscribe button. This way you will not miss new projects, new live streams and videos from VoxMeta team. So I was just talking about the scanning modes, and I talked to you about the one that I'm using right now, 34 crossline laser mode. And apart from this scanning mode, we have other two. The one would be the 17 parallel laser mode for intricate details, surface texture, and also fine details, right? And again, we have the last single laser mode. That would be the last mode of scanning, the single laser mode. It is designed for specifically reaching into deep holes and narrow slots, right? So I will demonstrate to you all these scanning modes a little later. So for now, we'll be using 34 crosslines in order to quickly capture everything. Here, let me adjust the exposure level so we can scan this black and reflective part. As you can see, it is extremely reflective and black. So it is a challenge to any 3D scanner out on the market. But with the usage of a higher level of exposure, we are able to fully, completely scan out this part. And so now we can move on to scanning the other parts now that we finished with this one. Also, we have black part here. I just love how this motorbike looks like. It is a very beautiful vehicle. It is one of my colleagues. So you can check it out. What do you think about the motorbike? So now let's move on to the lower parts. So yeah, also you can see how stable our connection is. It is because we have Wi-Fi 6 and Bluetooth connection for gigabit wireless transmission. So the connection is absolutely stable. Absolutely stable, no lags, no delays, no data loss. Everything works just fine. Absolutely stable. Once again. All right, from here, now we'll scanning the wheel. Wheel does contain a lot of surface texture. Also, some parts are really hard to reach. So we noticed some of you guys are asking about the specs of our PC. So currently we're running on RTX 5070 laptop GPU. Also we have a CPU of Core i9 14th generation, I think. So yeah, our specs are quite powerful. Also we have RAM of 64 gigabytes of RAM. So the minimum requirement, the least requirement would be Core i5 12th generation paired with RTX 2060. This is the minimum requirement, guys. And if you want to reach the same level of performance that you're seeing right now in front of your screens, you would like to have at least Core U7 155H plus RTX 4060. That would be the recommended specs of PC, so that you can fully unravel the full potential of the H1 Pro. Now let's scan this part. All right, even though it's highly reflective. Now, thanks to a high level of exposure, we are being able to capture it. Now, this part contains tons of hard details. All right, from this angle, okay, and for now we will be move out to here. So it's gonna take some time, as I said before, but that's okay. We have all the time in the world, so we can scan it out. I'm super excited for the results. This is the first time we're doing the full coverage of a whole motorbike, so I'm also very curious what kind of outcome we can get. from this project. I hope you guys are also really looking forward when we can finish the scanning and see the final result. So far we're doing really fine. I see that we have captured all the upper parts here. Now what we left is the lower part and the engine. I guess this would be the engine part. So again, let me adjust exposure to 2.5 because we have a very dark objects here. Let me pause and exposure level to 3. So, and now, as you can see, and one moment you want to pay attention to is the markers, the density of markers. The more markers, the more stable the scanning is. As you can see, we have applied a lot of markers on the object. So this is a mandatory requirement for any scanner, not only for ours. You will have to apply markers on the object in order to have a stable tracking. Also here, we're scanning the wheel now. I will probably miss some parts, but that's okay. For this type of objects, it is impossible to capture absolutely every detail. It is really time consuming and also energy consuming, you guys can see. But because we are using a wireless mode, so this is a really enjoyable process. It is really enjoyable process because 120 FPS is really a pleasure to eye. So we're almost there. What is left is some parts of the tail. Here we have So again, if you want to head out to our Kickstarter page, you can use the link on the live stream that we have attached to our live stream. You can use that link in order to visit our page. All right, we just scanned this part and we can call it a day. Also, if you guys remember this part, this side we scanned using the lower level of exposure, so we might have missed some parts, so we can fill them up. Now that we are using a higher exposure level, we can achieve a better capturing power. For instance, these parts. So these are the parts that we missed the last time we scanned. All right, also this one. So some parts I noticed that we have insufficient level of amount of markers, so I will apply some of them in order to capture it. So you see the parts that are not easy to scan. It is because we have not enough amount of markers there. So I will apply some of the you see this part. All right, and just like this. Also here. All right, let me pause and check out this one. So we almost finished. Let me run it one more time in order to make sure we didn't miss any spots here. All right, looks like everything is clean and complete. So now we can move on to processing it, right? So, and just like this, long press on play button, and we wait a little bit until the point cloud optimization is done. So currently we're working with 53 million points, guys. So this is a huge amount of data. So the program will take some time in order to process all of it. But due to the fact that we have a powerful AI-powered engine in our 3D scanner and the program itself, so the process of optimization is really rapid and fast. So I guess we'll take around maybe 1 or 2 minutes, or yeah, it didn't even take 1 minute to fully scan this motorbike. So here you can see the results. So here you can see, of course we could take more time in order to achieve a better result, but it is already not bad. So here you can see the details. Next we'll use a high level of point spacing. So that we can achieve a better details. Let's separately scan the wheel of the bike, and then we can scan the engine. I guess it's here, this part. We'll scan it using a high level of point spacing and exposure level. For now, this is the whole frame of the bike here. Let's go clean it up. We'll try to clean our 3D scanner from the unnecessary parts. And non-connected items. Right, this option is not really suitable for cleaning. So this would be it. We can use lasso option. Here we have lasso option. Just press Control and highlight the parts that you want to remove, and just like this. And now we can try to mesh it up. Let's use higher quality so we can mesh it up. So we'll have to wait a little bit until the meshing is done. For now, I can apply some markers on the wheel, because I noticed that we have not enough amount. And then we can scan it again using a higher resolution, right? The point spacing. So the meshing is going on, and then we can scan the engine from this side, I guess. Yeah, this is a windy day today, so So again, don't forget about our Kickstarter program, guys. That is about to be finished in 3 days. So you don't want to miss out your chance to get your hands on this professional industrial grade 3D scanner. All right, I almost finished applying the markers. And so later, if we notice that we have unstable tracking, we can add more markers on it. So for now, this is enough, I think. Talking about the specs, also we have a hot swappable system on our 3D scanner. You can see we have 2 lithium batteries here. You can switch them. You can even remove one battery, and the H1 Pro still runs on the other one. So you can change the depleted battery with a new one. So this is this option provides to you non-stop working 24/7. So you don't have to lose data or turn on your device in order to change the depleted batteries. So this is extremely convenient. Also, you can connect your 3D scanner to your mobile phone using a hotspot, and we have a dedicated app for Android and Apple phones, iOS system, the VoxMeta program. You can connect to the hotspot of your scanner, and you can watch in real time the scanning process on your phone. We have phone holder wrist. You can attach your phone to the wrist and watch the scanning process live. So we'll demonstrate it on the next upcoming live streams. So stay tuned. Now I can see the meshing is almost complete. After we have a look at the meshed object, we can move on to separately scanning the parts. Let's say this bumper here, we can scan this out. Also the engine part that contains a lot of details there. And again, we can scan the wheel. So the meshing is almost complete. So talk about the point distancing. You want to adjust the point distancing according to the object that you're scanning. And also your achieve a higher level of details. You want to adjust your point spacing to a higher level, to a higher resolution. This way, the scanning process will be a little slower, but the capturing power is much higher, and you get a much higher resolution, much higher details. So you want to take into consideration the point spacing, right? So we're at 99%, and we're almost there, because we are dealing with how many? With 15 million points, guys. So this is a huge amount of data. So it's naturally will take some time to fully mesh it up, and then you can later export it out as an STL OBJ file, and later you can import it into your CAD modeling programs, second part programs, in order to do a further processing, right? Whether it's inspection, research development, reverse engineering, etc. So this is the meshed object. So you can see how it is complete and full. Here we have all these details. Again, we could use some more time in order to achieve a better result, but still it looks fine to me. Here you can check the details. So this is the first time we're scanning this object fully. So we didn't know what kind of parameters use in order to scan it out. So now we have some idea of what kind of point distancing and exposure level we should use in order to better scan it out. So we'll try it one more time later. For now, we're gonna be scanning the separate parts, starting from this bumper, this part. We'll try to scan it separately, right? So you guys can see the details here. These writings, also here, the wheel. Huh? Alright, so let's check out this part. We have some laser parts here, and we have tons of writings. As you can see, this part was reflective. We have tail part, the blackish parts. Also this one was completely dark and reflective, but we managed to scan it out. Also check out these details. Also here, this one is engine, I guess. And this would be the wheel. You can see the writings are very visible. Let's check out from other side. You can see here a pretty solid scan, I guess. Let me save it quickly. Motorbike. So yeah, this would be the results. Check it out. Right now we can move on to scanning other parts using, let's say, 0.25. Start exposure from 0.5, and we will try to scan this part and see how it goes. So let me do this one and start scanning. So now we are using a higher resolution. So we have some interesting geometry here. We'll try to capture it. And move this side. Okay. Now for this part, we're gonna use a higher level of exposure because this one is quite reflective. So let me increase the level of exposure so we can capture it. So we're almost there. Let's run it one more time. Make sure we didn't miss no spots. So now this is it. We have finished scanning this part, and we'll wait until the point cloud optimization is done. We can check out the results. So now I can see that I have missed this part. So I can resume scanning in order to fill this up. So this is a very good option. So if you notice some spots that you might have missed, you can simply fill it up by scanning again. And now we can clean it up and move on to meshing. All right, now it looks pretty good. Time to clean it up. Let me choose the main body and the inverted choice, so we can delete these non-connected parts. Now we're left with the pure body. So we go to meshing and let's check it out. So this part has some interesting geometry, some writings and transition points here. So I'm really curious for the final result. So if you guys have any questions or suggestions, you can leave in the chat. My colleagues are ready to respond to you in no time. So meshing should not take too much time because this one is a smaller object, but still we have captured more than 5 million points. And the next one, we should move to the engine part. Engine part is also very interesting one. As you can see, we've been using the scanner almost an hour and we have 15% of battery left. And we have 4 more packs of batteries ready to go to work. If we run out of battery percentage, we can change the depleted one with the new one. So we're at 99%. We're almost done with the meshing. So the size of the motorbike is not a problem because our scanner can work with starting from 10 millimeters up to 5 meters, so we can even scan the whole car frame using our 3D scanner. So the whole body of motorbike is not a challenge. And here we have meshed object. So you can see very accurate point cloud. Here we have some text on the surface, these holes. Again, we could use more time to achieve a better result, but still, right now I'm super satisfied with what we have. So you can check this texture. It is the real texture of the surface. This is how it looks in real life. So the accuracy is really high level. You can see captured the surface, how it is looks in real life. This is a glossy object here. And this one is reflective part. We could use a high level of exposure to better capture it, but still looks quite nice. And here you have it. So this was a high resolution point spacing, to be specific, 0.25. Earlier we used 0.50, the default settings. So this one I think looks better than the previous one. Here we have it. Let me check. You can see the difference between these two. You can see how much more accurate the 0.25 point spacing is. So you can check out. You can compare yourself. Here you have it. This one is higher resolution, this is a lower resolution. So the difference is really distinct. Now let's go move on to the next object. Let me hide this. And that would be the engine part. Or should we start from the wheels? You choose, guys. I would like to start from the wheels, because this part is my favorite one. So let's do it. Put the PC. This position is good. Now we can start scanning the wheel using a high resolution. I guess I didn't create a new project, so it is started resuming the already existing project. So we have to wait a little bit. So yeah, we'll not be resuming this one. We're gonna be creating a new project and start scanning. It's quite hot outside. Even though it's cloudy, but the temperature is really high. And honestly, I'm sweating right now. So now you can see point cloud is being built. Let's use a higher resolution or a level of exposure. I noticed that we have not sufficient amount of markers, so I can apply some markers on the wheel. This way we have a better tracking. Let's say here, there. So you guys were asking, can we add markers during the scan? We recommend to you to pause scanning and then apply some markers, and you can resume the scan after applying. So this is not a problem. All right, now we're finished. Let's check the tracking. Now it is much more stable. All right, so we have glossy part here. All right, we're finished with this side. We'll scan it from the other side. Okay, we move to this side. Also, I have noticed we don't have enough markers here. This part. So let me apply some. and resume the scan. Nice. Now it is raining, guys. The weather was completely fine in the morning, but now it is raining heavily. Yeah, you can never predict what kind of weather you get during the summer. So now you can see the weather changed rapidly, and we have a completely another environment right now. At the beginning it was sunny and bright, but right now we are in a dark environment because we have a very cloudy, rainy weather. So you can see how our scanner performs under these conditions. So now we have finished scanning the wheel, and we can check out the results in a moment. Let's first clean it up. To be honest, I was not expecting this weather. And here you have it. So I would like to resume scanning from this part. I have noticed that I missed some parts, so I want to make sure So we have finished scanning. Let's check out the results. And here you have it. Let me clean it up. This option is not suitable for this scenario. So we go other way. We choose this one, this one. All right. Okay. Now we can get rid of these parts. And we have lasso option also. Now here you have it. Let's go mesh it up. The meshing should not take too much time. So yeah, right now we're working in a very dark mode. You can see the environment is really dark. We have lack of brightness right now. So this is a good demonstration both of scanning in a sunny, bright environment and in a black, dark environment. Now next we can move on to the engine part. Also, don't forget to subscribe to our Facebook group. We have updates every day on there. You don't want to miss out the new projects that we present. And we upload these scanned files there so you can download them yourself. Again, don't forget about our Kickstarter program. It is finishing in 3 days. So you don't want to miss your chance to get the scanner with a good price. So the meshing is almost there. We have 99%. We'll check out the results and then move on to the engine part. So right now we are dealing with 10 million points. It's also very big data, so no surprise it taking longer than usual. So here we have it. You can check out the results. You can see how accurate the writings are. How nice it looks, you can check. This type of holes are the result of poorly applied markers. So when applying marker, you want to make sure it is applied properly. So this would be the other side. You can see here. You can see the texture on the wheel. Yeah, so this is it. Let me save the project. And go back to home page and create a new project. So let me show you the specs of my PC right now. We have CPU of Core i9 14900HX with 24 cores. We have RAM of 64 GB DDR5 RAM. Of course, we're running on SSD. And we have NVIDIA RTX 5070 laptop GPU. So you have, guys, any questions regarding the scan, you can leave the comment in the chat. We are very glad to hear the feedback from you guys. So it's taking too much time, so let me just close the program. Open it one more time. Let's create a new project. Let's set the point spacing up to 20 and start scanning. We'll scan the engine part. So this one is quite hard to capture because it is dark. So that's why I'm gonna set a higher level of exposure so that we can capture everything here. So you can see we have some surface texture and other details. This one is also quite time consuming. So let me switch to 17 parallel laser mode. Also we have single laser mode, so that we can reach okay, let me zoom in so we can see clearly. All right, from this side. Also from this angle. Okay, almost finished. All right, I guess we can finish and see how we did it. And here you can check it out. Personally, I think the results are very good. You can see how accurate it looks. So now we have to mesh it out and check. Let's do closer to reality. So right now we are dealing with 7 million points. 7 million points. So what other part of the motorbike you guys want to see me to scan? Whether it's this part or that part, you can choose write in the chat, and we can try to scan it out and show you the performance wise of H1 Pro. So for now we have this one. So while we're doing the mesh, we can talk a little about the specs of our 3D scanner, the H1 Pro. So our scanner delivers 4.4 million points. With up to 4.4 million points, VoxMeta H1 Pro enables dense coverage of object surfaces. It accurately reconstructs fine details in one scan, significantly reducing the repeated passes and streamlining workflow for precision metrology and reverse engineering. Also, it offers a stable and responsive real-time preview, provides precision motion tracking for smoother scanning of complex parts, ensuring high-efficient field operations. And we have a built-in AI algorithms enable rapid point cloud processing. For the same volume of scan data, point cloud fusion and meshing efficiencies increased by 10 times, significantly reducing processing time and enabling seamless workflows across reverse engineering, quality inspection, and product development, right? And we have flagship AI main control chip. So now here we have it. You can check how accurate it looks, all the details here. Again, this type of holes are the results of poorly applied markers. So you want to pay attention to this point. Also, we have here this detail. You can check. So this one. Here we have deep holes. You can see how deep we can reach. So this was the engine part of the motorbike. So I can see some of you guys want me to use a higher resolution in order to scan the texture on the surface. So we'll do this and we go to creating a new project. We set our point distance, point spacing to 0.1 and try to scan it 0.5, let's say. Try to scan out. I guess you guys want to see this part because it contains a lot of texture and the writings. So we'll try to scan this part. So you can see that we are currently using high resolution point spacing. Even though the scanning process is a little slower, but the capturing power is increased several times. So we didn't adjust the exposure. It is on default settings. All right, this part is complete. So we can move on to this part. All right, also we have this one. So now we have completed scanning this part using the high resolution point distance. And let's see what we got here. So you can see the flagship AI main control chip processes massive point clouds with high-speed precision beyond basic imaging chips, providing professional computing support for industrial 3D scanning. So also we have equipped with an industrial-grade high-precision optical system. VoxMeta H1 Pro delivers 0.050 millimeters metrology-grade accuracy to faithfully reproduce every detail for inspection, reverse engineering, and high-end manufacturing, helping improve quality, consistency, and minimize production rework. Also, we suggest to you a carbon fiber scale. As a physical reference, the scale bar fundamentally reduces stitching, drift, and environmental cumulative errors, delivering truly stable metrology-grade accuracy for large-scale workpieces. Also, we have AI-based mesh feature extraction algorithm. With AI-based mesh feature extraction algorithm, VoxMeta H1 Pro delivers precise reconstruction of complex geometries, including holes, curved surfaces, irregular shapes, sharp angles, and vertical angles. So currently we are working with 56 million point, guys. So this is a massive, massive data cloud that is being processed right now. So it is no surprise why it is taking a little longer than usual. So while it's doing its work, we're going to talk a little more about the specs again. So powered by advanced optics and algorithms, VoxMeta H1 Pro ensures stable data capture across various materials and complex geometries, delivering consistent accuracy and seamless data integrity. It meets the rigorous standards of high-end manufacturing, precision machining, automotive and aerospace industries, and mold development. So we have integrated wireless dual connection. Unlike systems that rely on external wireless modules, the H1 Pro integrates wireless into a single device. Bluetooth-assisted Wi-Fi wireless connection delivers stronger connectivity, greater interference resistance, and dependable wireless performance wherever you scan. With the support of real-time preview on mobile phone, H1 Pro allows users to directly check the image, data coverage, and capture quality during scanning. Also, we have hot swappable design that allows you to replace depleted batteries while scanning, ensuring a truly seamless and uninterrupted wireless experience. And talking about the hardware, we have robust hardware base for consistent, reliable scanning, built with industrial-grade components across imaging, transmission, structure, and optics, ensuring stable performance, zero data loss, and consistent accuracy even in demanding environments and long-duration scanning. Also, we have industrial aviation connector, secure, vibration-resistant, and ultra-stable, designed for heavy-duty workshop use and multi-station shifts. This aviation connector eliminates connection drops and lag caused by poor contact, ensuring your workflow remains seamless and reliable. Also, we have aerospace grade aluminum body, precision engineered with aerospace grade aluminum body alloy. The scanner features high rigidity, lightweight construction, and strong deformation resistance. It maintains structural accuracy during prolonged handheld use, movement, and transport, effectively eliminating scanning errors caused by mechanical deformation. And now, let's see what we got here. And right away, you can see how accurate and precise this part looks. You can see the holes here. And you can see the writing, how clean and clear it looks even without meshing. And now you can see this texture on the surface. This is a black and highly reflective glossy object that we have successfully accurately captured. And this, you can see these geometries, writings, and you can see this texture. It looks the same as in real life. Here you have it. This is this one is glossy. This one looks perfectly fine. You're not going to be meshing it because it will take too much time, I guess. So we'll be just demonstrating to you like this. As you can see, we've been almost scanning it for 2 hours and we still have battery left. We didn't change the batteries here. Using so as you have seen today, we have scanned the whole body of the motorbike, and we successfully scanned it out, and then we separately scanned some demanding parts, as such this bumper and the wheel and the area of engine, and we have successfully showed you how we scan using a high resolution. Also,少了呀，刚刚0.1。 And the final task would be to scan the whole part again, but using the lower resolution 0.0. So we'll try to quickly scan the whole body part using these parameters, right? So let's jump into it. So the advantage of this mode is, although we lose the ability to capture a lot of details, but we can achieve higher speed and work efficiency. So you can see we're being able to fastly, quickly scan data. So it is a very useful parameters when scanning the details that don't demand capturing a lot of details on it. You can see how fast it is. So once again, this is a lower resolution scanning, so that's why we might not get too much details. But the speed is really increased.漂了，漂了。As you can see, here we have this part. So you can see how fast you can scan the whole body frame using 1.0. 关一下麦。 So now we have to scan the motorbike wheel separately. So this is a high scanning mode. You can see with a lower resolution. We don't have too much details here, but it is quite fast and quick. You can see. You can see. So this is the scanning mode for today, guys. We're wrapping out on this one. So we today demonstrated to you the higher resolution and lower resolution of scanning, and this one is the lower resolution, even though the details are not too dense, but we have captured everything accurately. So this is it, and if you're not subscribed to the channel, don't forget to subscribe, and if you like the live stream, you can put the like button, and we're looking forward to your attendance to our next live streams. So see you again, guys, in the next upcoming videos. Thank you. As we know, manufacturing precision and quality are often compromised by factors such as component deviations, fixture stability, welding deformation, and human error. H1 Pro delivers an incredible 120 FPS and 4.4 million points per second in wired mode. When used with a scale bar, it achieves a volumetric accuracy of 0.050 mm plus 0.02 mm per meter. This ensures an industrial-grade precision even for large-scale projects. But how does it perform wirelessly? Let's find out. Now we'll process a scanned model and check the results after mesh. This is the deviation map of the car side frame in Control X. Most areas are within tolerance, with only minor deviations visible. What do you think? Let me know in the comments.